Alright, number 36 is asking to compare the graph of the function with the graph of its parent function. So the absolute value function is remember it's a V shape with the vertex at 0, 0. So this transformation here is a reflection, so I'll just put ref for reflection over the y-axis. So when you do that with that graph, it looks exactly the same. Okay, so it looks exactly the same as a parent function, even though there is a reflection over the y-axis. For number 39, this one, the negative right in front of the x, would be a reflection over the y-axis, just like 36. But it could also be considered a reflection over the x-axis if you factor out the negative, if you just put it in front of the function, so it would look like this. So y equals negative. So these two, this one, and this is the same exact graph, the same exact function, but when you see it this way, someone would say, oh, it's a reflection over the x. And they're both correct. Number 42, it's a parabola, and that 1/2 is your a value. So this one is a vertical compression, I'll just put comp, by a factor of 1/2. Okay. Number 45 is the 4 is B right here. So we would say that this is a horizontal compression, because remember, even though it's 4, it's the reciprocal of 4, which is 1/4 that's changing. So horizontal compression by factor of 1/4. Now, here's a twist to this. I can also change this function, and the square root of 4 is 2. So I can rewrite it so that it looks like this, and it's the same function, right? Square root of 4 is 2. That's right. That's true. So the green and the black one are the same. When you graph them, exactly the same. So when you see it this way, someone could say, well, then this is a vertical stretch by factor of 2. By a factor of 2. And they're both right. Okay, for number 48, I went ahead and I used Desmos, and I took a screenshot of the graphs. Number 1 is the parent function. This is your f of x. Okay? And it's the red one, so if you look at it's this one right here. And then I went ahead and I typed in g of x, which is, what was it? F of x. Oh, did I? Whoops. Typed in the wrong one. Take it back. Let me redo it. Okay, so on the right hand side of the screen you have the value of h, 7. Again, we got it from here. And k is 4. We got it from here. So that means that the x's are going to be changing after we add 7, and then the y's are going to be changing after we add 4. Okay. Below that I put the vertical asymptote and horizontal asymptote equations. So let's go ahead and transform the points. So 7 minus 1 is 6. Oops. 4 minus 1 is 3. Then 7 plus 1 is 8. And 4 plus 1 is 5. So over here on this side, on the graph, let's see, change the color. I'm going to draw the vertical asymptote at x equals 7. So 1, 2, 3, 4, 5, 6, 7 right here. The horizontal asymptote at y equals 4. Okay. This is y, this is x. And then the point 6, 3. So that would be 6, 3 right here. And 8, 5 right here. So remember, that's all you need for the rational function, for the simple rational function with transformations. So those two dots and the two asymptotes, because you know that the graph goes towards the asymptotes. So there's one branch, there's the other branch, and for part D, you would write it, they want you to give, let's see, f of x minus 7 plus 4. Okay, for 63, the parent function is f of x equals the square root of x. The transformations are left 3 units, reflect over x-axis, a vertical compression by a factor of a half, and down 1. Okay, and again, I'm just getting this from here. So left 3 because this is h is negative 3. Reflect over the x-axis because the a is negative. Vertical compression because this number here, which is a, is between 0 and 1. And down 1 because k is 1. Okay, so now we're going to graph it. Okay, so for this one, the a, like I mentioned earlier, a is negative 1/2, k is negative 1, h is negative 3. And the only one of the 3 parameters that we have listed here, the only one that affects the x is h, by subtracting x by negative 3. So subtracting, by subtracting 3 from each of the x values is what I meant. Okay, so we're going to have negative 3 plus 0 is negative 3. Negative 3 plus 1 is negative 2. Negative 3 plus 4 is 1. For the y, though, it's a different story because these two parameters, right here affect the y. So when I have to make 2 changes, I just write it out, okay, instead of just doing it mentally. So I'm going to write negative 1/2 times y minus 1. And then, for 1, 1, the point 1, 1, I'm going to take negative 1/2 times 1 minus 1, and then for the last point, negative 1/2. Now this third point is not really necessary, but I'm just adding it in for good measure. Because if you know the shape of the square root function, the first 2 points are enough. Okay? So let's simplify. Negative 3, 0 minus 1 for the first one gives me negative 1, and then negative 2. Negative 1/2 times 1 is negative 1/2, so that I'm working right here. Negative 1/2 minus 1, so that's going to give me negative 1.5. And then for the last point, negative 1/2 times 2 is negative 1, minus 1 is negative 2. So 1 goes with minus 2, negative 2. So these are the transformed points right here. These are the ones I'm going to plot. Negative 3, negative 1, negative 2, negative 1.5, and then 1, negative 2. So it goes this way. Okay, so for the numbers 69 through 72, you start off with a function that has 2 x-intercepts, one at positive 2 and the other one at negative 3, like I had there on the graph. And then they perform some transformations on this function, and they want you to give the coordinates of the x-intercepts. Okay, so they want you to name the x-intercepts after performing the transformations. So in the 69, they're saying that the function is reflected over the y-axis. Okay, that's what this means, right? That the function is reflected over the y-axis. So that means that this point is going to come on over here, and this point is going to come on over here, okay, across the y-axis. So then the x-intercepts for 69 would be -2 and +3, okay, after you flip the graph. For number 70, this 2 right here means that there's a vertical stretch by a factor of 2. But remember, when you do vertical stretch, you're multiplying the y value by 2. But right here, the coordinates of the intercepts are 2, 0 and -3, 0. So the y is 0, right? The y is 0, so 0 times anything is 0. So for number 70, the x-intercepts will stay the same. Even though the graph has a vertical stretch, the intercepts stay where they are. They stay put. So the intercepts would be the same. So -3 and +2. For number 71, it tells you that the function has a vertical translation or move 2 units up. Well, then at that point, since you don't know anything else about the function, as soon as you move these 2 points 2 units up, we have no idea where the rest of the function lies. So this one can't tell. Okay? And for 72, this means that the function is translated to the right 3 units. Okay? So these 2 points right here are going to move to the right 3 units, to the right 3 units. So -3, 0 will now be, oops, forgot to change the pen. -3, 0 will now be 0, 0. So the x-intercept is 0. And 2, 0 will now be 5, 0. So the intercept is 5. The x-intercept is 5. All right, for the last 4 problems, you have to find the domain. And so for 83, we look at the denominator, and we look for values of, we don't want 0 in the denominator, right? So we look for values of x that make the denominator 0. And so 9 makes the denominator 0. The numerator, doesn't even have an x, and in most cases it doesn't really affect the domain unless there's a square root in the numerator, but this is not the case. So we say